Hi everyone, welcome to Offer Organic. In this video we will be discussing about oxidation and the simultaneously occurring another phenomena, reduction. Whenever a substance combines with oxygen, it is called as oxidation. The substance could be an element or a compound and the resulting product is called as the oxide. In our daily life we see a lot of examples of oxidation. One of them is rusting of iron. If you ever noticed a reddish brown powder on iron nails, this powder is called rust. Rust is formed as a result of a chemical reaction between iron and oxygen. And since we all know that oxidation forms an oxide, therefore rust is also a type of oxide. And because it is formed from iron, it will be called an iron oxide. Another common example of oxidation is combustion. In combustion, a fuel combines with oxygen to form an oxide. From combine here I mean chemical reaction. Chemical reaction can simply be put as a phenomenon where electrons are involved. They may be transferred or shared, but they are involved in any way. Most of the people think that during combustion a fire breaks out, but that is not always true. To understand that, let's first understand combustion. Combustion can be of two types, fast or slow. So as fuel we can use petrol, diesel, kerosene oil. These are also called as fossil fuels. Besides these we can also use wood, cow dung cakes, etc. So whenever we use any of these as fuel and make them combine with oxygen, a lot of heat and light is produced, and that is called fast combustion, which is seen in the form of fire. So if I have an engine and I put fuel and oxygen inside that engine and make them chemically react, a lot of energy is produced, which is used to drive your vehicles or automobiles. Our body also does the exact same thing what an engine is doing here. From body here I mean the body of any living organism. So what if I replace this engine with a living organism's body? Since we have a body here, the fuel would also be different. And what is that fuel? You all know that fuel, and that is food. So when you eat food, your body gets fuel, and when you breathe, your body gets oxygen. Now inside your body, this food and this oxygen, they chemically react to produce energy. If it had been a fast process, it would have produced a lot of heat, light and energy all at once. Now imagine the consequences if this huge amount of energy is produced all at once or a little fire happening inside your body. It would have definitely killed your cells. Hence, this process occurs slowly, continuously producing small amounts of energy instead of a large amount of energy produced all at once. And this is called slow combustion. And this slow combustion is given a special name called respiration, and it causes no fire at all. So whatever the type of combustion is slow or fast, it always releases energy. And one thing that is the most important for combustion is the presence of oxygen. And this importance of oxygen for combustion was first explained by a French chemist, Sir Antoine Lavoisier, and he coined the term oxidation for this entire process. Now let's understand what actually happens during oxidation. We just discussed that oxidation is reaction with oxygen. From reaction here I mean chemical reaction. That means a reaction in which transfer of electrons occurs. Let's understand this with an example. Like in our world, most of the fights occur because of money. Similarly, there is a world of chemistry as well, and like we have people, the world of chemistry has elements. And these elements keep on fighting with each other, and these fights are called as chemical reactions. And unlike our world, these fights are for electrons. E negative is the symbol of electron. Now there are some people who are generous, who have big hearts, and they will donate money easily. So they will be called as donators, whereas there are other people who are greedy and will accept money. So there can be various reasons why somebody is a donator or an acceptor, like rich or poor. Generally what we believe is that rich people donate easily and poor accept easily, but that is not always true. So this could be one of the reasons. There are many other reasons. Similarly, in the world of chemistry, there are elements that donate electrons easily, whereas there are other elements that accept electrons easily. So the elements that donate electrons easily are called as the electropositive elements, as they become positive after losing electron, whereas the ones that accept electrons easily are called as electronegative elements. Now if there is no donator, what would an acceptor do? And therefore donators always stay with acceptors. Same way, electropositive elements always stay with electronegative elements. And from stay here, I mean they form a bond with each other. And therefore electronegative elements gain electrons lost by electropositive elements. So you see there is a transfer of electrons, and therefore this bonding is called as chemical bond, because we already discussed that chemical bonding requires transfer of electrons. So what category does oxygen belong to? It belongs to this category, that is, it is an electronegative element, and therefore it will gain electrons. So oxygen will try to bond with all those elements that are ready to give electrons, that is all the electropositive elements. And therefore this electropositive element will undergo oxidation because it will lose electrons to oxygen. And what will happen to the other electronegative element? We use a separate term for this. We say this has undergone reduction. So we see that this greedy oxygen, greedy of electrons, has undergone reduction by gaining electrons lost by this electropositive element. So to sum this up, oxidation is like shaking hands with oxygen, where an electropositive element shakes hand with oxygen and it undergoes oxidation by losing electrons to this greedy oxygen. Now the question is, are there other elements also greedy just like oxygen? The answer is yes. Elements like nitrogen, fluorine, etc. are greedy just like oxygen, so they can accept electrons from other electropositive elements. Therefore, whenever an electropositive element will bond with an electronegative element like oxygen or nitrogen, etc., so the electronegative element will gain electrons, whereas the electropositive element will lose electron, and this process will also be called oxidation only. In earlier times, most of the oxidation reactions involved oxygen only, and therefore scientists named them oxidation reactions, meaning the reactions that involve oxygen or reaction with oxygen simply. But the term is a misnomer now, as there are a lot of reactions that do not involve oxygen but are still oxidation reactions. So the new definition of oxidation is simply the loss of electrons to an electronegative element. Now the question is, are there elements that are more greedy than oxygen? And what happens when oxygen comes in contact with those more greedy elements? The answer is those more greedy elements would gain electrons. And this poor oxygen has no other choice than to lose electrons to these more greedy elements. This means that oxygen undergoes oxidation, whereas these greedy elements, they undergo reduction. But who is that powerful enough so as to make oxygen undergo oxidation? The answer is fluorine. Fluorine is the only element that can make oxygen undergo oxidation. Therefore, fluorine is the most electronegative element. Now let's understand oxidation with the help of a molecule. This is a water molecule, which is made up of hydrogen and oxygen. At first you may think that this greedy oxygen will take away the electrons of hydrogen and will become negatively charged, leaving this hydrogen positively charged. The same will happen with the other hydrogen as well. Now since oxygen has taken 2 electrons, one from each hydrogen, therefore it would be -2. But in reality, this never happens, because neither the oxygen is powerful enough to completely take away the electrons of hydrogen, nor the hydrogen is willing enough to completely give away its electrons. Another option could be that both oxygen and hydrogen keep one electron each in between and share them, just like a covalent bond. But this greedy electronegative oxygen would never agree to the idea of sharing electrons with a tiny little hydrogen. So what would oxygen do? It would definitely share electrons with hydrogen, but the shared pair of electrons will remain slightly towards oxygen because it is electronegative. So when oxygen takes one electron completely, we give it a negative charge. But here, oxygen has not completely taken an electron. Instead, it has slightly displaced electrons towards itself, and therefore we give it a delta negative charge. Delta here means slightly negative. And since it has done this electron displacement thing with two hydrogens, therefore we give it a 2 delta negative charge. And both the hydrogens get delta positive each. Now this delta positive and delta negative written all over this molecule makes things complex and a little difficult to understand. Therefore, another term called oxidation state was introduced. Oxidation state means the current state or condition of the element inside a molecule. Like in this case, in this water molecule, the oxidation state of oxygen is -2. Which means that oxygen tried snatching 2 electrons from 2 hydrogens. It was an unsuccessful attempt, but it at least attempted. But if it had been an oxygen molecule where one oxygen bonds with another oxygen, oxygen would never try to snatch electrons from another oxygen, and therefore in that case the oxidation state would be 0 because there would be no tug of war of electrons between both the oxygens. So we say that oxidation state of oxygen is -2 in a water molecule. Similarly, the oxidation state of both these hydrogens would be +1 because oxygen tried snatching 1 electron from each of them. So in this case, since hydrogen is bonding with another hydrogen, therefore the oxidation state would be 0 each. Similarly, the oxidation state of this oxygen will also be 0 because it is bonding with another oxygen. And we just discussed the oxidation state of these elements in water. So oxidation state of hydrogen changes from 0 to +1, it increases, and that of oxygen decreases from 0 to -2. Therefore we say that this hydrogen has undergone an increase in oxidation state and therefore it has undergone oxidation. And the oxidation state of oxygen has reduced and therefore it is called reduction. So now you know what actually reduces in a reduction process. It is the oxidation state. So reduction is called reduction because oxidation state reduces during reduction. And since oxidation and reduction they always occur together, therefore they are commonly called as redox reactions.